Okay, so a linear function, obviously a graph is a line. Solution to a linear equation is any ordered pair that falls on that line. Which variable is dependent and which one's independent in regards to x's and y's? Which one is the independent, or which one's the dependent?
X dependent?
Is what?
Is X dependent?
No.
Y dependent.
Yeah.
I knew it was-
You know, it's one and the other. You got a 50-50 shot. So if you think about an equation, a linear equation, y equals 2x plus 1, the independent variable is the one you pick and plug in. So like x equals 2. When you plug in 2 and you run the calculation, that y value is going to depend on what you plugged in for x. So x is your independent, y is your dependent. Your y-intercept is where the graph crosses the y-axis, and that occurs when x equals 0. So you can see x is 0 and the y value is 1. The x-intercept is where it crosses the x-axis, and that occurs when y equals 0. So it's when the opposite letter is 0. And then we learned in Algebra 1 3 formulas for slope. The first one we don't really use that much, but I'll put it up. It's the vertical change. Oh, good thing that was in my grade book. On the video. The first one is the vertical change over the horizontal change. But instead of that one, we usually use rise over run, right? It's like but those are the same things. So that's how much you rise up, how much you run over. And then who remembers the formula if I give you 2 points, how you can calculate the slope? Right?
X says minus 1 is
Close, but no. Augie?
y is 2 minus 1 over x.
Yes, it's going to be your vertical change, so your changes in your y's, how much you're rising up, y2 minus y1, all over x2 minus x1. They're saying sub 2 because it's a little 2 underneath. It's a little subscript. And then we should remember y equals mx plus b, right? Well,
I hate this equation.
slope is our m value.
I love Y.
B is our y-intercept.
No, say it loud.
Y equals
I mean, it's
Mason?
X plus B is the easiest one.
Can you put like y1 minus y2 and then x?
1 minus x2.
Yeah.
Yes, as long as you subtract them in the same order.
Why do we do it the other way? Why do we put 2 first?
Why do we do 2 first?
Yeah.
I don't know.
Don't question how they made it.
All right. Graph each equation below. So we should know how to do this. We have our slope and we have our y-intercept. So we always begin at the y-intercept. So we go to our y-axis, we go to -1 and we put a point. Then we use the slope to move using rise over run. So 2 over 3 we're going to go up 2 and we're going to go to the right 3. So we're going to count up 2 and over 1, 2, 3. Up 2, over 1, 2, 3. And I didn't give you rulers, so just do your best. All right, connect the dots. This was on your summer pack quiz. Again, like 98% of you were
Varsity
fine
golf
with
is
this one.
dismissed at this time. Again, varsity golf is dismissed at this time. Thank you.
This one, our y-intercept is 3. Now, how do I do a slope if it's not a fraction? Jacob? Put a 1 under it. Okay, so we have -4 over 1. So since it's a -4, that tells me to go down 4. Do I go right 1 or left 1? Always to the right. Okay, if you were to go to the left, you would be indicating it was a -1, and then you'd have 2 negatives, which would really be a positive. So from here, I'm going to count down 4, and to the right 1, and to the right 1. Connect those with a linear function. Now, does anyone remember what form this is? This is not slope-intercept form. This is standard form. You have 2 ways to graph this. What's one?
Subtract X and Y by
Yes, you can subtract 4x. So get it into slope-intercept form is option 1. Subtract 4x. And this was on your summer packet quiz, right? Now, personally, I don't write it 8 minus 4x. I put -4x plus 8 so that it's in slope-intercept form, kind of. But a lot of you forgot to divide each number by 2. You have to divide every single term. Some of you did it and then you just messed up your division somehow. But you should get -2x plus 4. Okay, which we would start at 4, count down 2, over 1, down 2, over 1. Now, what's the other way you can do that without solving for y? Augie?
You can make like y0 and then just like solve for x, and then that would be the x-intercept, and then you can make x0 and then you can y-intercept.
Perfect. You can find the intercepts. Okay, so remember, the y-intercept is when x equals 0. So if you plug in 0 for x, which normally you don't do this work, you just kind of do it in your head. 4 times 0 is 0. If I divide by 2 on both sides, I get y equals 4. That means the y-intercept is 4. You would plot that. Then you'd plug in 0 for y. So we have 4x equals 8. Divide both sides by 4, we get x is 2. You would plot this. You would only have 2 points, though. This one and this one, the intercepts, and then you would connect the dots. So that's 2 different ways you can solve. I don't care which one you do. So this one gives us a equation, 10x plus 5y equals 40. Models how you can give 40 cents change if you have only dimes and nickels. The variable x is the number of dimes, so when they tell you x is the number of dimes on your graph, on the x-axis, you're going to label this number of dimes. Anytime it's a word problem and not just a graph, you have to label everything. Y is the number of nickels, so this is my y-axis. Graph the equation, describe the domain and range, and explain what the x and y intercepts mean. Now, since they want me to explain what the x and y intercepts mean, I'm going to solve using the intercepts, like Augie just talked about. So instead of subtracting 10x and dividing by 5, which you can do, I'm going to solve using the intercepts. I'm going to find the intercepts, since they want me to describe what they mean anyways. So again, to do the intercepts, all you have to do is plug in 0 for x, solve for y, plug in 0 for y, solve for x, and that will get you your 2 intercepts. So when I plug in 0 for x, 10 times 0 is just 0. Divide both sides by 5. We get y is 8. So that's my y-intercept. When I plug in y for 0, I end up just getting 10x equals 40. I divide both sides by 10, and I get x equals 4. So if you solve using intercepts, you only get 2 points instead of getting your slope and your y-intercept. And then you just have to plot those. So I would go up to 8 on the y-axis, and I would go to 4 on the x-axis, and then I would connect them. Now, I'm not going to go into the negatives for this one because you can't have a negative number of nickels or dimes. So it's really actually like a segment instead of a line. Okay, you also can't have half of a nickel or half of a dime, right? You'd only have a whole one. So I'm connecting the dots where they go through like actual corners, and that'll help with our domain and range. So they want us to describe the domain and range. Okay, so the domain is the set of x values or the number of dimes. So I could have 0 dimes, 1 dime, 2 dimes, or 3 dimes, or 4 dimes. Now be careful with the range. Okay, you can't have 0, 1, 2, 3, 4, 5, all the way up to 8. Because if you had just 1 nickel, you wouldn't be able to make 40 cents with dimes. Okay? So it would be, looking at our range, the y values, I could have 0, I could have 2, 4, 6, or 8. And again, that's because I'm trying to make 40 cents and change, not 35 cents or. The last thing we ask is to describe or explain what the y-intercepts mean. So the y-intercepts mean that you can make change of 40 cents with 8 nickels and 0 dimes. So it's kind of like the extreme, using just 1 coin versus a mixture of coins. This would be, we could use 4 dimes and 0 nickels. There's one on the homework like this. The numbers are much larger, so you may have to scale your axis, like count by 5s on one of the axes, count by hundreds or something. So just keep that in mind whenever you're doing those. Okay, let's also take a look at all the different equations we know for linear functions. So who remembers what standard form is? The general formula, Maren?
ax plus by equals c.
Perfect. Ax plus by equals c. Standard, alphabetical, and then number. Point slope. Point slope. Point slope. Augie?
Parentheses y minus y sub 1 times, equals slope times x.
Yes. The parentheses on the one side really aren't necessary, because this is the only thing over here, but if you like them, leave them. And that's when you have a point, which is your x1, y1, and a slope, m. And then slope intercept we already looked at. If you have forgotten these, you need to re-memorize them. So we're only going to do like example A from each of these, but again, if you need more assistance in these problems, I did B on a separate video. So write an equation in slope-intercept form and standard form from the equation of each for each given information. So we have a slope, we have a point. What equation would I choose to start with? Point slope. I only know enough information to plug in a point slope. Notice they didn't ask for point slope at all. They asked for slope intercept and standard, but I don't know what the y-intercept is, so I can't just plug stuff in. And I also don't know what a, b, and c are. So when you're given a slope and a point, you have to start with point slope. And then we'll substitute in our values. Our slope is our m, and this point is our x1, y1. Sub into our formula, y minus a negative 1 would become y plus 1. Negative 1/2 x minus 8. How do I get that into slope-intercept form? Distribute first, good. Okay, when you multiply a fraction and a whole number, you'll want to make that whole number into a fraction, put it over 1. Get negative 1/2 x. Now negative 1/2 times a negative 8 would become a positive, and 8 divided by 2 is just 4. Lastly, to get it into this format, I need to move the 1 over, so I would subtract 1. So I will get y equals negative 1/2 x plus 3. How do I get that in standard? How do I get it in this form? To have x and y on the left, right? Yeah, move over the 1/2 x. I see a negative, so the inverse is to add 1/2 x. You're just doing inverse operations like we did in our literal equations. So you'll get 1/2 x plus y equals 3. That's one possible answer. Does anyone know how you can modify that to make it look different but be the same equation without a fraction? Ryan?
1/5 x plus y equals 3.
Without a fraction or a decimal, I guess, I should say. Jackson? Yes, you can always multiply by the denominator, which will allow you to get rid of. You have to multiply all three terms by it, though. So 2 times 1/2 would just be 1x plus 2y equals 6. These are the same equation. You don't have to do the second one. I just showed in case you get a multiple choice question, and this is not an answer choice, but this is. So it's kind of like having 4/8 versus 1/2. Like they're the same thing. What do you mean?
Like the first one.
They wanted you to do both.
Oh, okay.
Okay. So you had to do both. But in regards to these for open-ended questions, like I would accept that as an answer if it were an open-ended question. All right, the next one, we'll skip B. Asks us to do the same thing, but we're not given the slope this time, we're given 2 points. So our first step would be, Augie?
Do y from 1
Good, we're gonna find the slope using that formula. y2 minus y1 over x2 minus x1. Point 1 is our x1, y1. And point 2 is our x2, y2.
Can we just use change over y or change over x?
Yes.
You like, okay.
No, as long as you, however you figure it out is fine. As long as you do it correct. So in the numerator, we should get negative 1 minus 5 is negative 6. 4 minus 1 is 3, and then if you can divide those, you should. So whenever we divide that, we'll get negative 2. Also, if it just ended up being a fraction, you want to reduce that fraction. All right, now we are going to put it in point-slope form. Does it matter which point I pick? No, you can pick either one, but most students like to pick, and this is my M, so most students pick point 1 because you are already labeled it x1, y1. So we'll sub in y minus 5 equals negative 2, x minus 1. So that's actually one of my answers because they wanted it in point-slope form. Then they want us to rewrite it into the two other forms as well. So we distribute. We add 5 to both sides. And then lastly, to get it in standard form, because they want all three forms for this question, we move the x over. So we'll add 2x, and we'll have 2x plus y equals 7. Okay, again, we're going to skip E, but if you need more practice or more reinforcement, watch that video that's online. Okay. The last thing on that page we have is graphing in point-slope form. How do I graph something that's in point-slope form? There's two options. Jax? You can distribute and get it into slope-intercept form. So you can actually distribute this and then add your 5 over. What's the other way, Augie?
Can you find a point, find a point line in with the correct slope?
Yes, you could actually use the point that is here. Now the problem is a lot of students mess up the negative, which is why a lot of students do what Jack said, which is to distribute and move it all around. When you pick this, the point would not be 3, 5. Okay, since the formula is x minus x1, this has to be x minus a negative 3. So the point would be negative 3, 5. And you can plot that point. Whoops. Then you can use your slope to move from that point. So down 2 over 3, down 2 over 3. Again, if you don't like that, I'll show in this example, you could just do your distributing. So we'd have 5x minus 5, and then we would subtract 1 on both sides. You could just get it in slope-intercept form. So whichever way you like, doesn't matter. As long as you can graph it. Okay. The last thing we're going to look at are special types of lines, which are parallel, perpendicular. We'll get through as much as we can. So they want us to find the slope of each line. This is like exactly what we did in the other problems. You would need to get this into slope-intercept form. And then you would need to just identify what M is. So just like we did with our literal equations, if I asked you to solve this for y, you know how to do that. Okay, you want to subtract 4 first, and then divide by 3. I will go through the fraction one, though, because I think some of you would struggle with that. Just make sure you realize that the only thing they want to know out of this question is what is the slope, and that's your M value, so your final answer should be just negative 4/3. That's it. Now, what would you do with the fraction one? You could subtract 2/3 x. Yeah, let's do it that way. I did it differently in period 1, but it doesn't matter. There's multiple ways to do this. And then instead of dividing by 1/2, we could, Augie?
When you multiply by a common denominator.
That's what I did in first period. So in the first period, I multiplied by 6, and then I got rid of all the fractions. Okay, that's the other option. Since Jack started me off on this, I'm going to finish it this way. So we would, instead of dividing by 1/2, we would multiply by the reciprocal, 2 over 1. Now whatever we do to this side, we have to do to this side. And you do want to make sure you distribute that too. So it would be negative 4/3 x plus 2. So the slope again is negative 4/3. I did those two examples on the extra video if you need them. Okay. The last types are our special types. And we looked at these on the summer packet quiz. I reminded you about these. The horizontal lines, remember? The slope for a horizontal line is 0 because it's flat. Those are when we say just like y equals 2, for example. We don't know what the number is there. Vertical lines are when m is undefined. So your slope is undefined. And that's when it's just x equals a number going up and down. And again, that's because this would be like 2, 0, 2, 1, 2, 2, 2, 3. The x value is always 2. Okay, perpendicular lines. There's a special relationship between perpendicular lines. Okay, the main attribute is their slopes have a relationship. Does anyone remember what the slopes relationship is? Augie?
Negative reciprocal.
Yes, negative reciprocal or opposite reciprocals. So their slopes are opposite reciprocals. So for example, if one of the slopes was 1/2, the other slope would be negative 2/1. So you flip the fraction and you flip the sign. That way one is always a positive slope and one's a negative, and they intersect with those right angles. The y-intercepts could be the same or different. That doesn't really matter. Now for parallel lines, what do we notice about their slopes? Yeah, same slope, different y-intercept though. Alright, so our last few examples just ask us to write equations of lines that go either perpendicular or parallel to a given line. So the first one says it goes through this point and it's perpendicular to this line. So the first thing that I would do is I would identify the perpendicular slope. For those of you not taking geometry, this is the symbol for perpendicular, just like an upside down T. I use it a lot in algebra too. So the original slope was 2, technically 2/1. So remember, the slope for perpendicular is the opposite or the negative reciprocal. So I'm going to flip this to make it negative 1/2 is my new slope. Now, because they also want us to graph this, you could actually graph it first if you want. You can plot this point for negative 3. So it's going to go through that point and it's going to have this slope. So use this slope to create the line. Go down 1/2, down 1/2. Also go up 1 and backwards 2. If you graph it first, you can then just look at the graph and say, what's the y-intercept? What is the y-intercept? -1. Then just throw that into slope intercept form. So we'll have y equals negative 1/2 x minus 1. Now if you don't like that, the other option would be to take this slope and this point and actually do your point slope. So if you're more of someone that's like in algebra, you like doing all your distributing, you would take and plug this into this, and then you'd rearrange it till you got there, and then graph that. Okay. See if you guys can try B while I pass out your homework. Now in the homework, you are going to do the odds only because I took 2 worksheets and put them together. So I'm just having you do half each, basically. The answers will be posted for all of them, so if you just want more practice. My Keystone test takers this year, this is like basically what's on Keystone. This is lesson. Right, guys? Did you agree with that? Joseph took it. Module 2 has like median mode and box and Western blocks and stuff, but Module 1 is like linear, lots of linear stuff.
Can I ask you that when it's done tomorrow?
Yeah.
I never got anything in the mail.
Let me show it the other way for this example, in case you were wondering what I was talking about. that one we should be getting y equals negative 3x plus 2. You can see I did it with point slope form this time instead of plotting the point and counting the slope. So a little bit more work for this one. People probably might like the graphing better. All the other examples I did on that second video, so if you need to see them when you're doing your homework or if you're struggling, just go click on the part 2 video and it's not as long as this one.